Welcome everyone to the seventh session of the LoongArch Biweekly, and we have quite a bit of news ahead of us, so let's begin. Before we start, this meeting is organized by Longsun Hobbyist Community, a third-party organization that is unaffiliated with Longsun Technology or any of the companies, entities, and institutions mentioned in this document. Please limit discussion to open information only. We will not answer questions for products and designs currently under development or testing. Please refrain from making political statements or commentary for the duration of the meeting. Opinions expressed in this meeting are strictly of the individual speakers. So to begin with upstream development, we have a couple news items from the GNU toolchain. I'll give the floor to Xiroyao.
Hello, can you hear me?
Yes.
So let's begin. We begin with being utils. The first notable change is the upstream developer Alan Modra. He fixed the LoongArch assembler compilation errors when compiling with GCC 4.9 by avoiding C99 style variable declaration after statements. Because the old GCC does not support such a declaration. Though I don't know why someone must compile the LoongArch assembler with such an old compiler. Zhao Zhou proposed a new option for OBG dump to annotate the disassembled dbar instructions with human-readable comments describing the memory operations ordered by the barrier, following the definition in LoongArch Volume 1, version 1.10. Yan Junyang reported a so-called corrupted global offset table issue in statically linked executables introduced by the PR 2965.5 fix, but I found the commit message unreasonable, so I investigated the issue further. The real issue is the R-LoongArch got PC LO 1212 and some of them are resolved incorrectly when the symbol is a GNU indirect func. The PR 2965.5 fix only activated the incorrect code path. A proper fix has been submitted and awaiting review. The next page. In GCC, two previously reported patches are already merged as is, so I will not repeat the details here. The new changes, there are some new changes though. The first is from me. I reported a mismatch between the register used by the caller and the one used by the callee. When the COBOL programs pass floating point arguments and proposed an ugly fix. The issue is in COBOL, the function calls does not use a prototype, every call is compiled as if the callee is variadic. But on LoongArch, when you call a variadic function, the floating point arguments cannot be passed via floating point registers. They are passed via integer registers. But when the function itself is compiled, it expects the argument in the floating point register, so it gets some garbage. The problem, I don't really know how to fix the issue, but I proposed a very ugly fix. It basically uses string comparison to see if we are compiling a COBOL program, and if so, we disable the special rule for variadic function. and I don't know if the fix is really acceptable or not. Bench submitted a patch to add a split rule to use only two bit string insert instructions for some bitwise AND operations in order to avoid materializing the large immediate. But the upstream reviewer Jeffrey Law comments it's better to implement that with an expand rule instead of split. And I tried the approach with expand, but I found the cost model will make the combine path, turning the bit string insert instruction pair back into a normal AND operation with immediate materialization. Because quoting from a comment in the cost model code, we will often be able to hoist the constant load out of the loop. It's unknown yet if this hack is really valid for the cost model, nor if the bit string insert, nor if using the bit string insertion pair is really an optimization, or maybe it in fact may regress the code. We have not performed a benchmark yet. The next page. In glibc, the first news is a comment from the release manager of glibc 2.44. The release manager, Andreas K. Hutel, stated that the test results for LoongArch are considered perfect, just like x86 and ARM. After 2.44 is released, I found some GNU programs, uh, some GNU programs, the test suite of some GNU programs failed to complete, and the investigation shows that the problem is an interaction between the newly added POSIX spawn file actions change directory alias and the GNU lib logic to probe if this function exists. The interaction results in an infinite recursion by calling the aliased POSIX spawn file actions changing directory np function. The np stands for non-POSIX actually. The issue is essentially architecture independent. We only post it here solely for the LoongArch distro maintainers. So they won't find their build bot trapped in an infinite test suite run or deliver the broken packages to their users. The non-workaround is rebootstrapping those packages from the Git repository to fit the latest GNU lib with the fix for the issue, or appending some variable overrides to fix the incorrect probe results. The next page. There are more glibc changes. Meng Qinggang proposed a fix for a rare crash during thread cancellation due to an intermediate value in the stack pointer register. The thread cancellation is implemented based on a signal and stack unwinding. So if the stack pointer contains some intermediate value, uh, when the signal comes directly at the same time point as the stack pointer register holds an intermediate value, the stack unwinding will fail and then the program will crash. So we saw the fix is to avoid intermediate value in the stack pointer register. You must calculate the final value in a scratch register and then move it to the stack pointer register. Yuri Krastalov reported that a test case from the LoongArch narrowing floating point mass function, like fdiv, fix did not anticipate architectures with optional floating point exception support, and the test case may wrongly report unsupported on the AH64 processors with the floating point exception implemented. And he fixed the issue by removing an incorrect or maybe not incorrect, just imperfect uh, mm, conditional directive in preprocessor and use the runtime probe instead. I reported that a test case from the previously reported LoongArch PHP-aware load segment aligning does not anticipate the variable page size configuration on other architectures. For example, MIPS64 or AH64, they have 4 kilobyte pages or 16 kilobyte pages. But the test case always assume the 4 kilobyte for those platforms. So um, so the test may fail on those architectures. And I proposed a fix to just raise the assume the minimal page size. The next page. So I'm done.
Okay, and when it comes to Linux kernel, there has been I guess a couple more visible changes. So starting with platform support, Liu Zixing submitted a patch to work around the backlight power state loss on the EAE CIS NL60R or the Excelsior NL60R laptop based on the Longsun 3B6000M chip. So basically the backlight would not come on after resuming from S3. And we found that the issue occurs on EC firmware version 1.11, but it doesn't happen with 1.9. So there has been so Liu has submitted a patch to basically make sure that the backlight state was set to off when entering S3 suspend. So it will always come on correctly. And the mainline has merged the patch and it should be made available to all the active stable branches down the line. Wang Hongliang submitted the 8th revision of the patch set to add clock-related properties and parsing and bus speed adjustment support for Longsun's I2C support, and this patch is known to fix touchpad cursor stuttering and lagging on some 3B6000M laptops, and Xiruo Yao and Ziyao has since tested this patch and it should be merged very soon. Jiang Haoran submitted a patch set to enforce write XOR execute principle on page tables, enable strict module RWX to enforce strict memory read write execute permissions, and add support to dump kernel pages tables on LoongArch. Zhao Qunqing submitted a patch to encode node and memory controller information into the eDAC information using ACPI's DSD property, MCIDX. So this should make basically ECC errors and ECC status easier to read and easier to identify which module connected to which processor node has returned an error. Zhao Qunqing also submitted the 5th revision of the patch to fix the multi-node support for Longsun's security engine. This revision mainly addressed the feedback from Sashiko AI, and this is a known issue with the security engine support on certain multi-processor platforms. As for how this security engine driver will be useful for down the line is still up for debate, because the support for kind of platform-specific cryptography drivers has been put on the chopping block last month, and it is yet to see what Longsun would do with this. Jovin being submitted the second revision of the patch to support thermal monitoring on 2K0300. This revision addressed code style suggestions from Kona Dooley, Hua Cai Chen, and Sachiko AI, and split it into multiple patches since V1. He also renovated the patch set to add the CanFD controller support to the sixth revision, which has been approved by Chen Huacai, which should now in turn be merged very soon. In the KVM subsystem, Mao Yibo submitted a patch to add support for multiple virtual machine ID to the LoongArch KVM subsystem. Not quite sure what it does. I don't really know enough about KVM. Cui Tao submitted a patch to support bulk control and status register migration using the KVM get set srex macros. This should make snapshotting vCPU states or VM migration should accelerate these operations significantly. Zheng Shi submitted the fix for program counter double events in a MMIO memory mapped IO read path in the KVM subsystem. Mao Yibo stated that the issue could potentially lead to critical failure and approved the patch. In the BPF subsystem, Pu Lehui fixed a memory leak in the BPF JIT-free function of the LoongArch BPF subsystem. Chen Huacai has merged the patch. Zhao Chengguang submitted the inline support for the new kernel pointer exchange function, BPF KPTR exchange, or BPF K-pointer exchange in the LoongArch BPF subsystem. This is probably a more general purpose performance optimization. There are also other functional and code fixes, and I guess perhaps less fortunate communication in the upstream space. But to begin, Jiang Haoran submitted a patch to fix oops errors triggered by single-step debugging after setting breakpoints using the KDB debugger. According to the author's description, this is caused by a mismatch of macros used to analyze problems, and kind of an inconsistent use of that function between LoongArch and AR64 and RISC-V. The patch is currently pending review. Wang Xuewen submitted a patch to add no check for map dbus in LoongGPU fix-up DMA hang function. This is a quirk function. Chen Huacai, however, was not very impressed and pointed out that the patch lacks factual support and is illogical. Wang later commented that the patch was indeed based on subjective assumptions and basically out of imagination, in other words, and gave up on the patch. Yang Tiezhu submitted a patch set to expand the virtual memory address space for kernel modules from 256 megabytes to 2 gigabytes, which is basically used by all other architectures, modern architectures, that is, in order to fix insufficient memory errors when loading large kernel modules. This really is more commonly found when trying to load the AMD GPU module with debug symbol, which, if you didn't know, the AMD GPU codebase accounts for more than 30% of the size of the Linux kernel source base. Yang Tiezhu also submitted a patch to replace the custom compare three-way macro with the generic compare integer macro that functions the same. And with LLVM, Wang Lei submitted 3 patches to help with inline assembly diagnostics and to simplify the control flow for linker relaxation and PCREL, or relative relocation handling, and remove the unused return value of add relocation. He also changed the logic of processing subsymbols in the LoongArch backend to generate relative PC relocations instead of add subpairs. This change resolved an issue reported by George J. Guo, which caused issues with LLVM's inline assembler. Wang Rui or Hef submitted a patch request pull request to allow using integer 128 value types with F inline assembly constraint when targeting LSX, or the 128 bits Longson vector extension. Although die 128 is not a legal LSX value type, it naturally maps into a single 128-bit LSX vector register in inline assembly. This will enable instructions such as vaddq to operate directly on the int 128 operands without requiring explicit vector types. Taiki Endo reported that the 128 compare and exchange operation using the SEQ instruction may return a corrupted value on CAS failure. Yentang made a couple suggestions to fix it up, but basically up till now this issue is the approach to fixing this issue is still under discussion. George J. Guo asked about the issue where the inline assembler emits a paired RLArch at 64 relocation instead of a single RLArch 64 PC rel relocation for the undefined symbol SYM -dot, which affects object tools live patch functionalities. And up to this point, I should also mention why there are on some of the pages there are timestamps for LLVM as of July 31st. That is mostly because of the editing contributors may not have time to update the newest upstream status after our weekly upstream updates, which you may find on the longfans.cn website. So I do apologize for that, but sometimes we just run out of time. And when it comes to Rust, Tang AAC submitted a patch to use Rust built-in intrinsic SIMD module to refactor the implementation for vector average with rounding to simplify the code structure. He also did the same to vector saturate to a specified number of digits operation. So this is really just code refactoring and cleanup. With .NET, Alexander Koplinger Kuplinger removed the Debian repo parameter overridden for the LoongArch platform from the .NET build tools prereqs Docker repository. So this is really because of the fact that LoongArch is currently is now an officially supported architecture in Debian, so it's no longer necessary to override it with a Debian ports repository. And Adil Mujahid modified the build process in Arcade in the similar spirit. Last month, Liu Wan submitted support for LoongArch atomic instructions for both LoongArch ISA version 1.0 and 1.1. The patch set is currently under intensive review from the JIT development team and is currently undergoing continuous iteration. EDK2 also saw two patches. Li Chao submitted a patch to add LoongArch ISA version 1.1 feature flex and enable hardware page table walker by default, which is, if I understood correctly, enabled by default and implemented correctly first with Longson 3C 6000. Qian Dongyan or Mastoge submitted a generator for adding ACPA MADT, or the multiple APIC description table, which previously required manual writing. MADT tables are currently typically found to describe buses and interrupt controllers in multiprocessor systems. And for box 64, I'll take a brief break and give the floor to Liu Yang.
Okay, box 64. So we have made some progress as usual. The first is we introduced the push pop ISP merge. So in x86 assembly, it's very common to have some push and pops in a row to do the function prologue or epilogue. So these instructions need to increment or decrement the ISP register. but we don't need to update the ISP register in every instruction. We only need to do it once at the beginning or at the end. So this is the optimization. So we merge the ISP update from into one add or sub. Next, we added some of the fast paths for some 16-bit instructions mainly. When these instructions met certain conditions, uh, when they don't need to update the E flags and some conditions similar, we can do it fast. So we added some fast path to that for the performance. Next, let me see. Oh, no, not next page. I'm reading the third bullet point. I don't remember what it is. Okay, this is a long-standing bugs. We have we have we can't figure out why for a long time. But this is fixed now. So it's a the dynamic bug that it may write some non-executable files into the cache, and now it's fixed. Next, we add some opcode fusion for the COMS instructions, and uh, it's relatively common to have a COMS instruction plus a conditional jump. So for these two pairs, for this pair, we can fuse them into one long arc instruction. So we did that fusion. Next, let me see. Oh, last month we added some upper 32-bit optimization, but there are some regressions, so we fixed some regressions. Next is a call return bug in the call file opcode, so we fixed that too. Next is exec 16-bit exec. The exec the first operand is a register, and the second operand is a memory. So if the memory register is the same register as the first operand, there is a issue before, so we fixed that too. Next we added some instructions to the dynamic, and next we fixed the e-flag simulation function, some small issues. And we also optimized the SHA-1 opcodes. Before we implemented the SHA-1 opcodes using C helpers, because LoongArch does not have any SHA-1 instructions we can use, so we have to do it softly. But this time we implemented it using some inline assemblies, mainly the LSX extension instructions from the LSX extension. So it's a tad faster than before. Next, we let me see. There are some instructions in x86. It needs to read the MXSR running mode to determine the running mode for the instruction. So before this optimization, we have to read the MXSR running mode from the memory, and we translate it into the LoongArch FCSR3, and then we can use some dynamic running mode instructions to do the math. After that, we have to put the FCSR back to the MXSR memory. But for this optimization, So we sync the MXR into the FCSR3 at the block epilogue prologue, and we sync it back in the epilogue. So if there is a hot code block doing a lot of the x86 running mode required instructions in a loop, this can be a lot faster than before. So next page. Next page, please. Okay. So for some simple functions, like they have very few parameters, so we can pass all the parameters in register. We don't have to touch the stack because the stack the stack for the parameters in x86 and in LoongArch is not the same. So for the functions, don't need to pass arguments through the stack. We call those functions the simple functions. And for those simple functions, we have a simple wrapper, so we don't have to save and restore all the registers. We can just pretend to be like we are calling a native instruction from the x86 world. So we added the floating point parameter support to the simple wrapper for simple functions. Before this, we only support integer parameters. We also make sure the x86 TCP is now consistent with the pthread itself. I think this fixed the Linux application called Winbox. Next, for the integer instruction fusion, before this, we only support 1+1 pattern. Now we support 1+n pattern. So we can fuse more opcodes after this optimization. Next, we added some safe jump optimizations. We can infer the we can infer the information from the x86 world. So and determine we have to use the safe jump or not. If we don't need to do the safe jump, we can remove some unneeded knobs. Next, Mikola added a new box it for option called dynamic disassemble. So this is for the DYDS disassembly in the dynamic dumps. This can be used to replacing the original hack, so the original hack is now be removed. This is for the developers to debug applications. Okay, I think that's all for mine.
Okay, thank you, Liang.
Thank you.
And we have other upstream updates, and Cyan is busy this week, so I'll stand in. And same as the LVM page before, and this is still news up to July 31st. So for issues and requests for assistance, Amber filed a ticket requesting LoongArch support in T-House, an intranet-only IP-based LAN instant messaging and file transfer tool. He is yet to receive a reply for how to proceed, but the upstream is interested in knowing more about Electron support in LoongArch. Martin Lishka added a cross-compiling CI container for images based on Arch Linux for the while linker, but he later discovered that the image did not support LoongArch as a cross-target, so that's maybe something to do for the Arch Linux folks. Sierra reported to Fuzzy CSR, a Longsun CSR fuzzing tool, that the global CSR read function is not working. Yuan Hecai filed a ticket requesting LoongArch port and LSX optimizations in Orbeck SDK v2, the Orbeck 3D camera SDK. The upstream responded that they will assess the feasibility, but also mentioned that if there is basically a commercial collaboration, it will go much faster. Zhang Xi submitted a request to distribute LoongArch binaries sorry, there's a typo here, not GitLab, GitHub CLI. The upstream responded that there is no such plan to enclose the ticket, but I submitted a pull request 3 days ago and basically added support for LoongArch, RISC-V, and PowerPC, and mentioned that, well, there's a lot of people asking for it. Would you consider maybe a community-supported architecture? To which the upstream maintainer has mentioned that they have discussed this before, but they will discuss again about the possibility of basically adding these three architecture as what he calls barely supported architectures. But in any case, distributing official binaries from the project upstream is good news for the user, and it's easier for people to get into and get the basically latest tools that they would need. And in terms of ports, optimizations, and fixes, Akizon added LoongArch build support for Komari Agent, an agent for the lightweight server probe, Komari Monitor. I submitted the flag for LoongArch seccomp audit support to OpenSSH. So libseccomp was officially supported since early 2025, but the ability to enable such support in OpenSSH was never added. CalicoCat 3333 added LoongArch build support for Arrows OS, a web desktop operating system, and fixed CPU frequency and hardware model detection on LoongArch. Darky Joe rebased AOSC's unofficial Chromium patch set to 148. It is now available for Electron and other applications. Liu Yu 3966 fixed 32-bit compressed values. An issue where the 32-bit compressed values were not signed extended in the JavaScript engine v8. LXH fixed IRQ redirection and SMP zone support for HVisor, a Type 1 bare metal virtual machine manager, and hardened VirtIO IRQ and zone startup logic. He also added image build and zone address validations to HVBoot, the UEFI bootloader for HVisor. Skybird fixed incorrect array size for community maintained fork for app image tool, the tool used to build app images, and this will make the fix will make the tool work again. Sorry, there's a repeat here. Subotech fixed a lower bound write overflow in Wasm time and Wasm runtime by reserving the fiber stack space before saving registers. At the end of, when it comes to DuckDB, a SQL database management system, last year Wu Xiaobai has already submitted a patch to support LoongArch. This support patch was finally undergone all the revisions that it needed and is now merged. So the next release of DuckDB should officially support LoongArch. He also added LoongArch build support to the community maintained fork of BuildKit, a container build tool. And Xu Xiaowei added LoongArch binary build workflow to FastFetch, a popular system information tool. The upstream has merged the pull requests and should basically start distributing LoongArch binary since the next version. And also from Xu Xiaowei is binary distribution flag to Go Container Registry, a container registry management tool and library for the Go programming language. The patch has already also been merged. Yuan Hecai submitted a fix to segmentation fault that occurs during updates and kernel copying on double precision, real symmetric matrices. The patch is currently under upstream review. Jay Supaki submitted a basically a for optimization for Q40 quantized models, based on LASX, the 256-bit vector extension. According to the test, the models PP512 and TG128 return test scores improvements of between 66% and 7% respectively. And it also shows a slight speed boost compared to the OpenBlast backend. Distro and operating system updates. First of all, we have tips for maintainers. The LoongGPU and LoongVPU both saw the first general availability releases for API 2.0 systems. They're currently available for download from longnix.cn with support for Linux kernel 6.6. But AOSC has ported the kernel mode drivers to Linux 7.1 for the GPU driver and 7.2 for the VPU driver. There are still, unfortunately, a couple issues with the VPU driver, as we have found during testing. OBS Studio's VAPI accelerated encoding seems broken. It produces green and garbled videos. Chromium may crash when decoding videos, and GStreamer VLC produces garbled videos. Previously, when it comes to CPU voltage and frequency scaling, that was now introduced with firmware 2026-05. It seems that without further patching, the mainline kernel is still broken. You might see boot hangs and incorrect frequency displays. Now, there is better news because Chenghua Cai has already prepared a set of upstream ready patches, and it's already been tested on 3A6000, 3B6000, 3C6000S, 2K3000, and 3B6000M. We have tested them for functionality in both in terms of frequency scaling down and up or turbo frequency of 100 megahertz on a single core. But testing on larger scale servers or multi-processor platforms are still undergoing. We are still experiencing several issues, but I'm sure they will be fixed very soon. So if you look at Chenghua Cai's Linux tree and pick the following 5 patches, this should fix CPU voltage and frequency scaling on most platforms. And Debian, in 2 weeks ago, Wang Miao reported that an incorrect fix for LDR alignment in BinUtil's 2.47's release candidate 1 has broken kernel modules. Debian has since fixed this issue by uploading the final release of BinUtil's 2.47, which includes the fix, and with Linux kernel 7.1.6-1, which has been rebuilt with the new toolchain. With AOSCOS, Linux 7.1 is now available from the stable repository with support for the previously mentioned pre-upstream patch set for SMC based CPU DVFS. Xi Ruoyao and Liu Zixing, which were responsible for porting the LoongGPU and VPU drivers, has submitted them for merging into stable. The GPU is now merged, but VPU, as mentioned, has a lot of issues, so we kept them in a preview repository. You may still test out the VPU driver via the following series of commands. But please note that the LoongVPU driver only supports 2K1000LA, 2K2000, 3000, and the 3B6000M. Other highlights from the past 2 weeks include ROCm the ROC 7.14 and ImageMagick 7 now being the default version, whereas previously it was ImageMagick 6. And I should also mention that with ROCm the ROC 7.14, there is only now 2 patches remaining from making LoongArch work out of the box, at least with the base components. There are more work to be done with the extended libraries and the Python modules like PyTorch, but I'm sure it will improve down the line. And finally, between July the 19th and August the 4th, we have released 35 security updates addressing 8 critical and 80 high-severity vulnerabilities. And to the right is our QR code to our Telegram group, and if you would like to join us and communicate with us regarding your ideas or bug reports, please do so. And now with Proxmox VE, I'll give the floor to Wukayang.
Hello. For Proxmox VE, the current state for the port is that the port is pretty much finished. You should be able to use it normally, and let me know if you encounter any issues in the port. And new updates from the upstream are constantly pulled. And you might be wondering, how about upstreaming? Because this port's final target is to be upstreamed. Uh, Despite that, upstream may not officially support LoongArch very soon, we still like to see the upstream support one day. Next page. So for the upstream work, we have contacted the Proxmox CTO and the Proxmox sales team for potential business collaboration to provide the official Proxmox VE LoongArch support to the Chinese market with Longshan hobbyist community. And the CTO has confirmed that the architecture is not necessarily a blocker for such collaboration and referred us to the sales team. For now, we haven't heard back from the sales team, but we'll keep waiting. Other than that, I have also submitted several architecture independent fixes and multi-architecture support enhancement patches to the upstream. And five of them, they actually just merged one of my patches like 20 minutes ago. So five of them have been merged to the upstream. Next page. So what's the current state of the upstream multi-architecture support? Well, I cannot finish this port so quickly without the upstream great effort on making Proxmox V more portable. So as some of you might notice, Proxmox V has been secretly adding the official ARM64 support since March. The earliest effort on the ARM64 virtual machine support can be traced back to January 2025. And we just got the news last night that they now they have published the official ARM64 installation ISO. So I guess ARM64 is now officially supported. And these changes to make Proxmox V runnable on ARM64 has made this project really easy to port to a modern architecture with good QEMU, KVM, UEFI, and Linux kernel support, like LoongArch, right? So thanks to the folks from Proxmox to make great effort on making it more portable.
Okay, thank you,
That's it for
Wukayang.
Proxmox.
Thank you, Wukayang, and hopefully we'll hear good news down the line. And for Alta Linux, we once again have Baltayev.
Hello.
Yes.
For Alt Linux, we finally released Alt Server. You can see link here. Also, Alt Atomic start to port their product to LoongArch, and I hope soon will be released too. We have some updates on packet base. Linux sampler is in progress, and shader slang and cosmic tasks are updated and can be used. It's not here on the slide, but we actually ported, not ported, but turned on GPU drivers for 2K3000, and it's working on Alt. Also, feel free to send an email to longarchbuild.ru if you like to port or test your software on LoongArch here in Russia. That's it for us.
Okay, thank you, Baltayev. And finally, we have news from OpenWRT. Packet Please, or PKT PLS, submitted an update for Linux kernel 6.18 to OpenWRT. This will now allow OpenWRT to run on unpatched mainline kernel for LoongArch. The patch has been tested, but is still undergoing iteration with reviews from their AI bots. But it's basically another example of LoongArch's mainlining work for their current platforms paying off. And that should be all for the updates from the past 2 weeks. And we will now turn to questions from both Bilibili and the Zoom meeting. Nego mentioned signals were a mistake, but we must live with them. But what are we referring to with the signals? And we have two questions from Bilibili. One being that is LoongArch ISA 1.1, the so-called old world API, old world. Well, there are a couple misconceptions here. Basically, first of all, let's explain what that really means here. So LoongArch ISA versions are basically the instruction set architectures being implemented in different chips. The 1.0 really refers to the 5000 series. The 3A6000, the 5000 series, the 2K1000, 2K2000 are both, they're all 1.0 implementations. With 1.1, we have 3A6000, 3B6000, 3C6000, and of course the 2K3000. They're all ISA version 1.1 implementations. And the old world is really referring to basically the binary ABIs that you find with ELF binaries, say in Linux. It doesn't refer to the firmware, doesn't refer to the ISA, doesn't refer to anything else. It's strictly what it means is the binary ecosystem, if you will, of LoongArch. And there has been efforts to try and come up with a kind of a more accurate naming for the new world and old world, because they really refer to a lot of things in a LoongArch system. But as is very evident, the old world and new world is a very catchy name. It's difficult to find as good a name for it as we do previously. But yeah, and the other question being asking, why is it now possible to upstream Proxmox VE support for non-x86 architecture? As Wu Kaiyang has mentioned, ARM porting has been worked on since earlier this year, and it's now official. And with that ARM port, you basically see, what we see is improved, how should I put it, improved infrastructure for basically introducing multiple architectures and basically ways to adapt PVE to different platforms. And you'll continue to see this if you look at LoongArch's port on GitHub. It's not only trying to fix up the paths to the QEMU binary, the modules that need to be loaded, yada yada, but something as detailed as how the CPU info file is laid out is a little bit different to x86 and ARM, and that basically drives the kind of the model display for the processor invisible. And you also have to take into account whether page table walker is available on a certain platform, is KVM available on certain platforms. So there are a lot of architectural details when it comes to that. For instance, the 2K3000 and the 3B6000M are really stemmed from embedded and low power IPC systems, and they do not come with virtualization support. So on those platforms, the PVE really becomes a platform to manage container applications, not so much virtual machines. So we would then have to design appropriate prompts, appropriate warnings for users installing on those platforms, telling them what's available and what is not, and hide menus that are not applicable for certain platforms, etc. So most of the work are not really the porting work in the how should I put it, in the coding and assembly sense, but really in terms of making it work like a normal and complete product on LoongArch. And Wu Kaiyang in the past couple months has really done a great job, and you would be surprised at how little patches there are over the upstream Proxmox VE because of how standardized and upstreamed LoongArch support is. And that really makes upstreaming a possibility if all the kind of business interests and investment are aligned. So hopefully we'll have better news down the line. Do we have any questions from the Zoom side? Okay, seems not. So let's move on and basically the preview for next meeting. And we will meet again in 2 weeks on August 20th at the same time. So hopefully we'll see you there. And thank you everyone for joining. And good night to people in China, and good afternoon, evening, and morning, etc. to others all over the world. And thanks again for joining, and goodbye.